Hey King, so here's example 1. There are 2 examples for you to try, part A with a square root and part B with a cube root. So if you want to pause the screen so you can try it on your own and check back in a minute, I'll continue solving them now, so when you turn it on you can check your answers. So I broke it into 2 parts. The first one is y1 equals the square root of x plus 25 and y2 equals 2. Then I'm looking for the x-intercept, which means y equals 0. So I set that up. I square both sides, and I'm able to see that x equals negative 25. So that gives me the point negative 25, 0. Finding the y-intercept means I have to set x equal to 0. So I'll get y1 equals the square root of 0 plus 25, which means y1 equals the square root of 25, which is 5. So our y-intercept is 0, 5. In order to find one more set of points, I think I'm kind of tempted to use positive 25. So I've got negative 25, 0. I've got 0, 5, and if we use positive 25, what will we get? So 25 plus 25, so that's going to give us the square root of 50. The square root of 50 is what? Oops, square root of 50, 7.1, approximately 7.1, which makes sense. So let's put a graph in here. That seems, now notice, we've got between 0, what we're looking for, y2, is going to be the line y equals 2. So on this one, we will definitely see the intersect point on our graph, which is kind of exciting. It's the little things, people. Okay. So, let's see here. We said, what should we go by? Should we go by tens on the x-axis? 5, 10, 15, 20, 25. Yeah, we'll go by 5. And then, maybe we'll go by 1/2. So this will be 3, this will be 6. That's kind of confusing. Okay, let's see how this plans out. So 5, 10, 15, 20, 25, 0 is our first point here on the table. We've got 0, 5, so this is something like this. So that should be 4.5, so this should be 5 right here. And then we've also found 25 to be 7.5, so, or just above 7. So this is going to be 1.5, 3, 4.5, 6, 7.5, so it should be right around there. So here's the curve this time. Again, remember, this one's a square root. So here are 3 points. Let me make those a little bit larger. Okay, and then we have y equals 2, and because of my wacky counting system, that should be right in the middle here. I'm going to use a ruler for this because you know me. So let's see. Oh, that looks like a terrible point. How are we going to be able to, can we even estimate the, yikes. I don't even think we can come up with whatever the x value this is. Ah, oh no, we'll have to solve it for sure. Okay, so close your eyes. Open your eyes. Okay, so the square root of x plus 25 equals 2. When does that happen? I'm going to square this side and square this side. I now have x plus 25 equals 4. When I subtract 25 from both sides, I get x equals negative 21. Does that seem reasonable? Yeah, actually, that's pretty good on our graph. So that's our answer, and you can see on the graph that that would totally work out. That it's reasonable that this point right here has an x value of negative 21. So that's good news. Okay, close your eyes. Open your eyes. Okay, so same strategy here. We'll call this y3 is going to be 2 times the cube root of x minus 3, and we'll say y4 equals 4. So that either will be easy to remember or completely confusing. So looking for the x-intercept, we have y equals 0. That means 2 times the cube root of x minus 3. So if I divide this by 2 and this by 2, I will still get 0. So we have the cube root of x minus 3. But cubing both sides still leaves me with 0 on the left and x minus 3. So it seems that 3 is going to be the x-intercept. Does this make sense? I mean, so if this is an x minus h, then of course the x-intercept is going to be 3. That's the only thing it can be. So that's kind of nice to see that symmetry in other types of problems having the x minus h factor show up again. Okay, so in this case, the y-intercept, I'm going to let x equals 0. So we have y3 equals 2 times the cube root of 0 minus 3. I'm kind of getting careless with my handwriting. I'm sorry about that. So this is 2 times the cube root of negative 3. And working with my calculator, I put it in like that. I think you can, there's not a glare in the wrong spot. So I get that y3 is approximately negative 2.9. Okay, so now our table will need a couple more values. So what have we come up with so far? So we've got, let's go with negative 3, and we had, oh, I'm sorry, I didn't even write that down. This is 0, negative 2.9. That's the piece of information I'm wanting. We came up with positive 3 was 0. So what else do we need? What do we think is going to get us? So the y-coordinate we're looking for is 4, and we're not there yet. So how far from 0 to 3 got us 3? Maybe we should go 7? Let's go with 7. Now it's not linear, so this isn't completely foolproof, but let's see what happens. Okay, so first of all, when we plug in, we're looking for y3 when x is negative 3 to fill out this square of our table. So that's going to be 2 times the cube root of negative 3 minus 3. So we have 2, can you see this on my calculator? Negative 3 minus 3 is negative 6. We'll raise that to the 1/3 power, and that gets us negative 3.63. So this is about negative 3.6, that works. And what happens when we plug in 7? It'll be what, 7 minus 3? So let's see here, 7 minus, so we have 2 times the cube root of 4. That gets us 3.17. We're going to call that 3.2. Oh, darn, it's not far enough. Do we want to use this one, or should we switch it up? Doesn't matter. Okay, 3.2. We'll go with this. But it's not linear, so maybe we should have gone with 9. That probably would have worked. I guess we can hypothesize and then we'll solve it and see what really would have happened. Okay, so we've got our 4 points, which is good since our index was 3, so that's kind of our goal. Our rule of thumb here. Sorry, probably need Dramamine while you're watching this. Okay. So again, what do we need here? Should we go by 2? I'm going to go by 2's on the x-axis because I'm thinking about that 7. And we can go by 1's on the y-axis. Okay, so we have negative 3, so this is 2, 4, so negative 3 is in this neighborhood, and negative 3.6. 1, 2, 3.6 should be around there. 0, negative 2.9 should be right above negative 3. 3, 0 is here, and then 7, so 2, 4, 6, 7, and 3.2. 1, 2, 3.2 is right around here. So this one goes like this. That's right. Okay. Okay, so I'm sort of estimating how this turns up here. And we said our other point was 1, 2, 3, 4, our other line rather. So let's see. So this one is y4, this one is y3. Okay, so can we estimate that point? Let's see, 7, this is 8, I think it's about 9. Let's see what we get. Okay, we have 2 times the cube root of x minus 3 equals 4. We'll divide both sides by the coefficient of 2. That gets us the cube root of x minus 3 equals 2. We have to cube everything, so we'll have x minus 3 equals 8. When we add 3 to both sides, ooh, I was way off. X equals 11. 2, 4, 6, 8, 10, 11. Yep, I curved it. It should be smoother here, so that it should be growing less rapidly, I guess is what I'm trying to say. Okay. If you just came back, oops, here are 2 graphs and our 2 answers.